Well, thanks for joining us on a lovely sunny afternoon. Hopefully, maybe even as you were walking along the mall out here, you might have seen some dragonflies. They're still out there flying right now. So maybe afterwards, if you didn't, maybe afterwards you can go out and sort of watch for them cruising up and down. So what I'm going to do in the next 40 minutes is to tell you some stories about dragonflies, hopefully tell you something you don't know. Always important to learn something new. Now, how many of you know about dragonflies? You've all seen dragonflies flying. You've seen the adults. So everybody knows what the adults look like. So they're great flyers. But they do a lot of really interesting things under the water. And I have a few specimens outside, and I'll show you those afterwards. So what I want to do is tell you some stories about some of the really remarkable things that dragonflies are able to do. And there are three main things I'm going to talk about. One is the amazing way that they work as predators. So both the adults and the babies, the larvae, are predaceous. They feed on other invertebrates and sometimes fish and tadpoles. They also have jet propulsion, which is kind of cool. So you all know about jets and you've seen them going. So they don't always use their legs. And they're also territorial. So I'm going to tell you a little bit about each of those kinds of things. So first of all, you've seen them in flight. These are the adults. They're remarkable flyers, and there are a lot of different species. And in fact, just like with birds, there are people who actually go out dragonfly watching. And you can buy books. This one is the Dragonflies Through Binoculars. And this is a field guide to the adult dragonflies of North America. So you can actually go and, with your binoculars, watch the dragonflies, and you can try to identify them. And it tells you almost exactly the same things as you would have in a bird book. It tells you what to look for, what kind of habitat they're in, what time of year you would see them, what their range is. We even have a book like that for British Columbia. So if you haven't seen this book and you're interested in dragonflies, this tells you about the 80 species of dragonflies and damselflies that we have in British Columbia. And it gives you all the identifications for how to tell them apart. And when you're in the field, you can use that to try to tell them apart, because there are quite a few. How many of you knew we had 80 species? Does that sound like a lot? Yeah? It takes a lot to learn them and tell them all apart. Okay, so we're going to learn just a little bit about how to tell some of the groups apart. So you don't need to know the scientific names, but the group name for them, we call them the Odonata. So that's the only scientific name I'm going to give you today. But we have two main groups of Odonata. One is the dragonflies, and the other are the damselflies. So the damselflies are the ones on the left, and they're all very slender. So their bodies are quite slender. They have wings in the front and back that are very much the same. And so one of the names that separates them is the scientific name for this group says that the wings are kind of equal. They also tend to put their wings to the back. So they're poised behind their back. Whereas the dragonflies, the back wing is always bigger than the front wing. And so they're slightly different. And they almost always have their wings out flat. As well as that, the body is quite large. So those are the main ways to tell dragonflies from damselflies. So we have quite a few damselflies. We have quite a few dragonflies. And most of what I'm going to tell you about today is mostly about the dragonflies. So they are a bit different. And so we'll start there. So as a group, the adults and the larval stages of dragonflies are predaceous. The adults are terrestrial. You've all seen them flying around. But the larval stages of all dragonflies and damselflies live in fresh water. Okay, so unless you've gone looking through fresh water, you won't see them. But there are quite a remarkable diversity of these dragonflies. Now, the other thing that's interesting is dragonflies were here long before the dinosaurs, long before even most of the fishes. So the dragonflies have a very long history in evolution. And we have fossil evidence that some of these dragonflies got to be almost 75 centimeters across. So that's about this big. Now, what do you think they would be feeding on when you had such a big dragonfly? Tiny little flies? Yeah? Probably big flies. Yeah. So, yeah, exactly. So 250 million years ago, there must have been some very big invertebrate prey available to these big dragonflies to make it worth their while. So, and we know that they were still predaceous even back then, but we don't know very much about what they fed on, other than that there were lots of other invertebrates that were around at the time. Okay, so I'm going to tell you 3 stories. The first one is that the larvae have hydraulic jaws. So the jaws are actually operated with a hydraulic force that's not just muscles. And it's pretty amazing how they use that. And that's their main weapon for catching prey. The second thing is that the larvae have this jet propulsion I mentioned. And it really is just like jet propulsion. They take water into their abdomen, they squeeze it out, and they fly ahead. And that gets them away from predators. And the last one is I'm going to talk about the adults flying and the fact that they're territorial. And often they're just like birds. They'll actually defend a stretch of wetland or stream against other adult males. And the females will come in and select her preferred male. Okay, so let's go through some of those. So first of all, the dragonfly life cycle. So I've already mentioned the larvae are found in water. So they hatch out of eggs. The eggs are tiny. And as they grow, they get bigger. So this is kind of what the nymph looks like, or the larval stage. When it gets big enough that it's ready to emerge and become an adult, it crawls up something along the edge, whether it's a piece of wood or a piece of plant, and it splits open. And you know that at each stage, it sheds its skin. Now, I'm going to show you some more pictures like that in a minute. But that's the basic life cycle. So once the adult is out, the adult will fly around. Some adults will actually fly around for almost 2 months, getting even fatter before they will reproduce. Some of them reproduce fairly quickly, but some of them will stay around for a couple of months. Okay, so here's some pictures of larvae. Now, one thing you need to know about these larvae is they're not like caterpillars and things that make a cocoon. These things develop their wings while they're larvae. So if you look here, you can see the wing pads. So these are just like wings developing under the skin. You can see it here. You can see it here. So these are animals or insects that we call have incomplete metamorphosis. Okay, so they don't go through a cocoon stage. When they're ready to become adults, they just split the skin, the wings are already there, and they just puff up the wings. So that means that they can fly away really quickly thereafter. It also means they don't have to go through any stage in their life cycle where they're really vulnerable. Because in a cocoon, lots of things can come along and eat a cocoon because it can't run away from anybody. Okay, so this is what it looks like. Once they're ready to emerge, the larvae will crawl up on a plant. So there's the larvae. It's crawled up on a reed here at the side of a pond. And it starts to split the skin. And the adult starts to come out of the skin. There's the adult hanging upside down. So it's leaving its larval skin. There's the adult. And now it's trying to get into position. Now it's completely out of its skin. So you can see the wings here. They were hiding inside the larval skin, and now they're ready to expand. And that's what they look like when they first come out. You might have seen this with butterflies. Butterflies, when they first come out of their cocoon, they have to spread their wings and make them flat. This is what a dragonfly's wings look like when they first come out. They have to pump them up. And all those little veins, you can kind of see the veins in here. All of those veins actually have fluid in them. And so they actually pump fluid into there to make them stiff, to make them expand. And then finally we get what looks like our adult dragonfly. And it's pretty much ready to fly. It takes a few hours. Usually it likes to stay there for a little while for the wings to get a little hardened. Because when it comes out, the wings are very soft. And they don't fly so well. But if you disturb them, they can fly. But usually if you don't disturb them, they'll sit there for an hour or two. And then it'll look like that. And once it's ready to go, it'll fly away and go feeding. Okay, so that's the basic life cycle. When they are ready to mate, usually the females will come back to the pond after the males. So remember, the males have territories. So the males set up territories, the females come back, and we don't quite know how they choose each other, but the females probably come and probably choose amongst the males. And you might have seen this before. This is actually when they get together, the males hold on to the female. So here's the male on the top. He actually has some claspers at the end of his abdomen that actually hold the female around her neck. She holds on to his abdomen, and when they're ready to mate, they fly around like this for a while. And the male will actually fly, carrying her around with him. So we'll talk about that a little bit more later on, too. So dragonflies are amazing flyers. I'm going to show you a couple of quick videos just to show you how amazing they really are. So these are all sleeping dragonflies. So in the morning, it's cool. So most insects, remember, they're cold-blooded animals. If they're cold, they don't fly very well. So they lie there and they wait for the sun to come up to help warm them up, but they can also move their wings very quickly to help warm them up. Okay, so this is in super slow motion. So it's got all 4 of its wings going here. I don't know what he's saying, but don't worry. Okay, so they're being territorial, and I'm going to show you in a second here. This will go into a section where there's males fighting with each other over their territories, and they're chasing them around. Okay, so here they are. These are actually some darners. So this is one of the largest types of dragonflies we have, and you can see them chasing each other there. And they're actually fight with each other. So at the end, it turns out one male doesn't do so well at the end of this competition and ends up in the water. So we're almost there. So you can see they're chasing each other, and they're defending their territories. And here they grab each other, and one ends up on the water. Okay, so he didn't do so well. So, but they are territorial, and they do fly pretty well. So let's see another picture here. This is a dragonfly catching its prey. So I said that they're great flyers, and they're great predators, and they eat a lot of insects. And the way that they catch their prey, you'll see this guy go up and catch this insect in a second. They actually catch it with their legs. So they create kind of a basket. Did you see that? They create kind of a basket underneath. They catch their prey, and then they'll usually go back to a perch and then move it up, and then they can eat it. So, so that's one of the ways that they catch their prey, and they're pretty efficient at doing that. So they're pretty amazing flyers. You might have noticed that one had numbers on its wing. They don't normally come with numbers. This is from a scientific study where they were trying to identify individuals. See the numbers on the wings there? So you can do that with dragonflies because, remember, they're territorial. So you can tell individuals apart. You put the numbers on, and then you can prove that they're actually defending a particular area. So that's why those numbers were there. Scientists do some strange things sometimes. Okay, so I told you that these guys had hydraulic jaws. So let me just tell you what their jaws look like. This is the larval stage now. We're going back into the water. Okay, when we look at under the head, so here's its eye, here's the mandibles. It has this extra piece here called the labium. And it's got 2 joints. And people started to realize this operates too fast for it to be just muscles. Because this particular piece sits underneath the jaw like this. So when it's sitting in its normal position, they have the front piece of the labium right in front of the jaw. And when they're ready to shoot, it goes out like this, catches its prey, and comes back to where the mandibles are. Okay, so let me show you the little bits. So you don't need to know the details of this, but this is what it looks like from underneath. This is the head again. Here's when it's fully extended. And so Japanese scientists decided they were going to try to figure this out. And they did all the scientific kinds of things. They figured out there's no muscle that's big enough and can't operate fast enough to do this. And they started measuring the hydraulic pressures inside the jaw. And they were able to show that, in fact, it is hydraulics. Now, I'm going to tell you how hydraulics work in just a second. But this is what it looks like with a time-lapse image of it. So here's the dragonfly larva. So it's still got its labium underneath its head. Here's the prey in front of it. Now you can see it starting to react. There, the jaw's starting to open. You can see it starting to move forward and move forward again. Here it's almost fully extended. And at the end, it catches its prey. So in this case, they don't actually let it catch the prey. But that moves out incredibly fast. It takes less than 2 milliseconds for it to go all the way from under the head out to catch its prey, and then hopefully catch its prey. Okay, so here's a, did you see that? That is so fast. They're in slow motion. Now it's catching mosquito larvae, so that's a mosquito larva here and here. Let's see if it actually catches one. There we go. That was so fast. There's no way muscles could operate that fast. Now that's not a good place for a mosquito to be, is it? Right in the jaw. Anyway. Okay, so they're feeding with those hydraulic jaws. They move so fast that the prey just doesn't have much chance getting away from there. But you also saw it orienting. It ate that poor little fish. It will actually take huge prey, tadpoles and fish. Fish have to learn to stay away even from the dragonflies. Okay, that's enough of that. That's scary stuff. Okay, so yes.
Is that because you were showing how they catch their prey with their legs?
Okay, that's the adults.
Okay.
When they're flying. This is the larval stage.
Okay, got it.
Yeah, these are the ones in the water.
Okay.
Okay, so this is again with the jaw expanded, the labium extended out to catch prey. So they're really efficient predators, and they can catch all sorts of different kinds of prey. Usually mostly other little invertebrates, but they will catch tadpoles and fish that get in their way. And you might have seen it. It was actually watching its prey. They have very good eyesight, so it actually will follow its prey around, just getting ready to strike. Oops. Now, it's not just dragonflies. So dragonflies, the other group that I mentioned, the damselflies, they also have the same labium here. So you can see it underneath this larval damselfly. They look a bit different as well. I told you the adult damselflies are really skinny. The wings are equal. The larval damselflies are kind of the same. Long, skinny abdomen, kind of like the adults. The one difference that the larvae have is that they have these great big gills at the end. They don't have jet propulsion, which the dragonflies do. So we'll see that in just a second here. Now, some of these will actually sit and wait. So some of them, I showed you a second ago, they're kind of hunting, they're following their prey around. These guys just sit in the bottom. This is a particular group you can find around here. They actually bury themselves in the sand like this usually and hide away. This one obviously was buried, but it's probably being disturbed for the picture. So just watch. Every once in a while, these brine shrimp go by, and just watch what happens. You've had brine shrimp before? Yeah, they're kind of fun to watch, aren't they? So this guy's just sitting there watching things go by. Yeah, Japanese. I wish I knew what it actually said. But he just sits there waiting and munching away. And I think there'll be another one in just a second here. It's a pretty nice way. You just wait for your food to come to you. Okay, I think we've got one more. And if you haven't seen brine shrimp before, these are they swim upside down. They're kind of weird little invertebrate crustaceans. Oh, there goes one more. You can see it's still struggling there. Okay, that's enough of that one. So, two other groups that you might be familiar with that also have hydraulic jaws, or at least capture apparatus, are the praying mantis. So again, the praying mantis has these, very much like the labium on the dragonfly. These reach out very quickly, catch prey. And again, the muscles can't possibly do it as fast as a hydraulic system. So these guys use a hydraulic system as well. Has anybody ever heard of a mantis shrimp? Yeah? Okay, so mantis shrimps are really cool. They're, maybe we should talk about them another day. Some pictures. They're so incredibly brightly colored, and if you go to some of the markets in Southeast Asia, you can eat these things too. But that's kind of the colors they've got. They actually have many layers in their eyes as well. I'm not going to talk about them today, but the reason I was mentioning them is they also use hydraulics. They have a club. So literally, they hit their prey, again using hydraulics to move that at really high velocities to stun their prey, and then they can eat them. And so all of the mantis shrimps, there's a fairly large group of them, they have these clubs underneath here, and they use hydraulics to just send them out with incredible force, stun their prey, and then they can catch them. So the hydraulic system that we have in these dragonfly larvae has evolved several times in many other groups of invertebrates. So all arthropods, of course, but it's shown up several times. So a hydraulic system. I'm just going to spend just a second to explain how hydraulics work. Usually, if you have a hydraulic system, you have some sort of liquid enclosed in the system, And the nice thing about hydraulics, and the reason that big trucks and cranes and all sorts of things work, is that if you put pressure into a small chamber like this, there's this really neat amplifying system, so that you put a little bit of pressure into here, and you can actually lift forces that are many, many times the pressure you apply. And there's a multiplication you can figure out. You can figure out what the area of this is. But it allows you to put just a little bit of pressure in one side and end up with huge amounts of pressure on the other side. And that's how we have cranes and all those big hydraulic digger trucks and stuff. That's how they work. And that's exactly how the dragonfly uses its jaw. It has a small muscle chamber. It contracts the muscle. It pushes the fluid forward and then allows the jaw to go out forward at a rate that they couldn't do with just muscles alone. Okay, so it's a hydraulic system. Very cool that nature has figured out stuff like that before we did. Okay, this isn't working very well. Now, that's another dragonfly larva. So this one is slightly different from before, but this area down in the back here has an open water chamber in the back. And so I'm going to tell you about how that they move. So they use jet propulsion. And what the animal's allowed or is able to do is the abdomen inside fills up with water, and they can actually squeeze the muscles of the abdomen that will allow it to push the water out back, and that allows them to use jet propulsion to get away from their predators. So I'm going to show you again some more videos here. So in this one, they're tormenting it with a little pencil. But see, it takes its legs, it pulls its legs in, and all of a sudden it's going around. Watch, there's no legs. They're not using the legs at all. It's not like they're swimming. Okay, so now he's back to using the legs. They're going to torment it one more time. Okay, so they're using jet propulsion to move. It allows them to move faster than if they were just crawling. And so that allows them to escape from their predators. This is a slightly longer video, but this is kind of fun. So when they need to escape from predators, they can use this jet propulsion system. And so here's the larva going across the bottom here, probably being scared along by the diver who's taking the pictures. But they also do this when they need to move into the shore, because when they're going to emerge as adults, they need to be able to crawl up something, and usually that's in shallow water. So the other thing that's kind of fun here is if you watch this, now watch the legs out front. When it's using its jet propulsion, it's got its arms out front, almost like Superman. Now there's two possible hypotheses. So we don't really know why they have their legs out there, but if any of you have taken swimming lessons, usually they tell you to put your legs out for balance in part, or your arms rather. So maybe that's what they're doing, and maybe the other one is that it helps them to, when they land, it's something to land on. But anyway, they all seem to do that, at least for this family. And it's pretty efficient. He's just going along. He's going to cover a lot of distance. And in just a moment, we're going to see another family of dragonfly doing kind of the same thing. So just watch this for another moment. See, they kind of blend in pretty well with the bottom as well, don't they? Okay, maybe we can move that one along. Okay, so here's the other type. This is another family of dragonfly. These ones are called the Aeschynidae, or the darners. And again, you see him swimming around. He's being disturbed again by the diver who's in there. You can see all the mud and the current that he's facing. So there he's back on the bottom with his legs down, and he's going to get disturbed. And now there he's going again. See, he tucks in the legs in this time. So a little bit different from the other dragonfly larva. And so this is probably moving towards the shore, or maybe just getting away from the predator. But it does allow them to move pretty quickly. Okay, so we've already learned they've got hydraulic jaws that allow them to catch prey. And now they've got jet propulsion. Wow, this is pretty cool. Okay, so at some point, they do come out as adults. They do fly around. And there are lots of different kinds. They all have really bright colors like this in the males. Often the females are a little bit less brightly colored. That's probably like with birds. that the males are trying to advertise and the females are mostly trying to be kind of hidden from things. Now, one of the other things that's kind of neat about dragonflies is that some of them will move long, long distances. So when they come out of the pond, remember I said they might spend almost 2 months feeding? Some of you might live a long way from the nearest pond, and you might still see dragonflies in your backyard or your front yard. Anybody live a long way from water, seen dragonflies around? Yeah, sometimes 2, 3, or 4 kilometers. So they'll fly a long way, and they're going to spend a lot of time just feeding. And what they do is they fatten up, even as adults. So even though the larvae eat a lot, the adults continue to eat, especially the females, because the females, of course, have to put energy into producing eggs. And so the females will actually spend longer foraging than the males do. But when they're ready to reproduce, they come back to the water because they have to lay their eggs in the water. So there are lots of different kinds of dragonflies, and this is the stage where you actually can go dragonfly watching. If you want to get a book like that, you could go dragonfly watching. And I mentioned at the outset for those who were here when I started that there's actually a Dragonflies of British Columbia book from the Royal BC Museum that is essentially the same sort of thing, allows you to identify the adults. Not very many guides allow you to identify the larvae because most people don't go and get wet in the water. Okay, that's another group of dragonflies that we have around here, the meadowhawks. So, a couple more cool facts that I wanted to tell you about before we wrap up. There are some dragonflies that not only fly long enough distances to show up in your backyard, kilometers away, there are some that migrate. We have at least one species here, and there are several in Europe, that actually migrate thousands of kilometers. So this species, Anax junius, found in Canada, will actually fly down to Texas and northern Mexico for the winter. That sounds like a very sensible thing to do. So the adults of the late summer generation, they'll actually fly all the way down there. They'll go through another generation down the south, and then new adults will fly back. In some cases, there's actually evidence that the same individuals that fly south will actually fly north in the springtime, and they'll start to reproduce as they come north and leaving subsequent generations along the way. But that's pretty cool that a dragonfly can actually fly thousands of kilometers. I said they were territorial, kind of like birds. They defend their females kind of like birds. And some of them even migrate like birds. That's pretty amazing. Okay, you saw those pictures with the larvae. They were kind of watching their prey very carefully. They have excellent vision, both as adults and as larvae. They have many, many facets to their eye. As scientists, we still don't know how they integrate that information, but they have about 1,000 little fragments in their eyes that we call ommatidia. Again, you don't need to know the name, but if you look at them close on, you can see that there's all these little separate eyes. And somehow they integrate all that information from each one of those in the back of their brain. Hard to figure out what's going on in a dragonfly brain, but they do have excellent vision, and we can see that part. Okay, they can also thermoregulate. So I told you that they're cold-blooded animals, which means first thing in the morning, they're very easy to capture. In fact, for those who are entomologists, the people who study insects, if you wanted to catch dragonflies, the best thing is to go out before the sun comes up, because the dragonflies are all really cold, they can't really fly, and you walk around the edges of wetlands and you can just pick them up. But as soon as the sun starts to come up, and before the sun's warm enough to warm the bodies of these, they actually will vibrate their wings. And if you watch them at that time of morning, you can actually see them vibrating their wings. And it helps to warm up the muscles enough that they can start to fly before the air temperature is warm enough to allow them to do it by itself. Okay, so they can thermoregulate a little bit. Okay, so I hope I've convinced you that dragonflies are very cool because they're such great flyers. They catch their prey on the air. They go long distances. They're very acrobatic, and they defend territories. They have hydraulic jaws. It's something you couldn't even have imagined, in a transformer set, how well this works. They have jet propulsion. Long before we invented jet propulsion, these guys were using it to get away from their predators. And then finally, they're just kind of fun to watch.